In the previous video, we looked at the introduction to second order non-homogeneous differential equations. Of course, coming up with the general solution of a given differential equation, of course, that is non-homogeneous by method of indetermined coefficients. And remember what we said was for method of indeterminate coefficients is when, let's say, you are given your d2y dx2. Okay, of course, you multiply by a constant plus, let's say, b dy dx plus cy is equals to your f of x. This is when your f of x is either a trig function, an algebraic function, or an exponential function. That is when we use method of indeterminate coefficients. Okay, so in case you didn't watch that video, check the link in the description. It would be very helpful if you watch that video before you watch this one. In fact, if you haven't watched that one, I advise you watch that one before you come to this one. Okay, so let's look at some examples. Let's say we are given d2y dx2. Is that plus? Let me say minus dy dx minus 2y is equals to 8. So the first thing that we do is that we need to solve the homogeneous differential equation. You might wonder, why am I talking about homogeneous when overall is non-homogeneous? Yes, it's non-homogeneous, but the first step that you have to do always solve the solve the homogeneous differential equation, of which is just this pattern. We need just to come up with the auxiliary equation of that. That's going to be m squared minus m minus 2 is equals to what? Will be equals to 0. So the product is negative 2, the sum is negative 1. So you're simply saying m squared plus m minus 2m minus 2 is equals to 0. So in this case, you have like your m plus 1. So you have like negative 2 m here. Here I'll say plus 1 is equals to 0. So we have our m to be equals to negative 1 and m also being equals to what? Being equals to 2. So these are real distinct roots. Okay. So what it means is that it takes us back to what we were talking about when it came to homogeneous differential equations, the possible solutions. When you're talking about real distinct roots or real different roots, you're going to say your y will be equals to your a by e m1x plus a e m2x there. So in this case, you're going to say your y is equals to your a e, then now your m1, I can say my m1 is 2x plus let me name this, let me put this as b, not a. Okay, so let me say b e minus minus x there. Okay, so now this happens to be the complementary function that we were talking about in the previous video. Like, you're going to say your y, let me name it as my y's ycf there. Okay, complementary function is equals to a e to the 2x plus b e to the minus x. Okay, so what follows now is that we need to come up with the particular solution. So it will be y p s, but before we do that, we get it from our f of x. In this case, our f of x is equals to what? Is equals to 8. And because our f of x is a constant, so meaning our yps, okay, yps is going to take the form c. Okay, it's going to take the form c. And when you look at this, your c as a constant, the way it is, it's not appearing in the what? In the complementary function. So you can go ahead and do the substitution, but before you do the substitution, we need to differentiate. So it's more like you have your y ps being equals to c, then your y prime of ps is equals to 0. Your y prime of the ps particular solution is going to be equals to what? 0. So we need to substitute in what we have here as our differential equation. We have d2y dx2, we have a 0 minus dy dx is also 0 minus, we are going to have 2. Our y is what? We put c there, is equals to what? Is equals to 8. So you observe to say in this case, divide both sides by negative 2, negative 2, our c is going to be equals to what? C is going to be equals to negative 4. So now you can come and say, okay, my general solution, okay, you say c is equals to negative 4. Okay, that's what we get as our y is equals to c, which in this case is our particular solution, okay, by method of indeterminate coefficients. So we are going to say our general solution, okay, general solution is equals to our complementary function plus our particular solution. So in this case, our complementary function is a e to the 2x plus b e minus x, then the c there are adding, they are going to be minus 4, and that's the general solution that we have right there. Okay, so let's try to look at another example. So then the example that I'm going to give right now is when there is need for you to multiply the particular solution by x because it appears the same as in the complementary function. So let's say we are given something like d2y dx2 minus y is equals to e to the x. Okay, so what happens now is that you observe to say, first of all, solve the homogeneous differential equation. That's going to be m squared minus minus the 1 there, which is the coefficient of y, is equals to 0. So meaning your m is going to be equals to positive or negative what? Positive or negative 1. These are real distinct roots, or distinct real roots, however you call it, is one and the same thing. So y complementary function is going to be equals to a e to the m1, I'll say is positive 1, so that will be x, positive x there. Okay, so so I'll say here plus b e to the minus x there. Okay, that's what we have. So what you observe is that your f of x is going to be equals to what? E of x, e to the power x, which is this one here. So we are trying to relate our f of x to what? Our f of x to the particular solution. So in this case, our particular solution is going to be equals to c e to the px. In this case, our p is a 1, so you just say x there. So you observe to say your particular solution is still appearing in the what? In the complementary function. So you need to multiply that by what? By x. So what will happen is that this is going to be y particular solution there, ps there, not pc. That's going to be equals to cx e to the x, like that. So remember, my aim is to substitute in this equation that I have. So I need to differentiate this. Okay, so, and I don't need to find no, I'll need to find the first derivative so that it helps me to find the second derivative, but I'll not need it when substituting. So this is going to be our y prime of the particular solution is going to be equals to this is, we use the product rule there. That's going to be like that's going to be something like cx e to the x. Okay, then I'll say plus ce to the x. Okay, it's like I maintain this one, I differentiate this one, I get c. Then if you maintain this two, you differentiate this one, you still get the same thing there. Okay, so you can come now and determine the second derivative. That's going to be y prime of the particular solution. That's going to be so at this point you just replace with everything here that you have. So that's going to be like cx e to the x plus 2ce to the x, because I was going to add another ce to the x there. Okay, so that's why I've just written it as 2. So now we can come and substitute there, where we are going to say, okay, this is going to be cx e to the x plus 2ce to the x minus our y. Our y in this case is what? Cx e to the x is equals to e to the x. You observe to say we can factor out the what? We can factor out the e to the x, so I can just erase it just here. This goes, it goes, it goes, it goes there. Here I remain with what? I remain with a 1. So this is going to be cx plus cx plus a 2 here, 2c minus cx is equals to what? Is equals to 1. So we can still factor out the what? We can still factor out the do you need to factor out anything? No, this goes and that goes, so remain with the, you say divide by 2 here, divide by 2, so meaning c is equals to 1 over what? 1 over 2. Okay, so it basically means your particular solution yps is equals to, where you have your c here, okay, where you have your c, you put 1 over 2, so that would be like x e to the x divided by what? Divided by 2. So you can come and say the general solution now. The general solution is going to be equals to my complementary function plus the particular solution that I have already found. So my complementary function is a e to the x plus be minus x. Then the complementary function we say plus what? X e to the x over what? Over 2. And that's what we have as the general solution. So for that one, I just wanted to illustrate what you do or how you go about it if you have your particular solution appearing in the what? In the complementary function. Okay, let's try to look at I've looked at an example that has an exponential. Let me try to look at one that has a trig function. Okay, so let me say we have d2y dx2, okay, minus 2 dy d 2 dy dx plus y is equals to 4 4 sine x. Okay, so in this case, once again, come find the solution for your homogeneous differential equation m squared minus 2m plus 1 is equals to 0. Okay, so you can factorize this, is going to be m squared minus m minus m plus 1, so that would be like m minus 1 minus 1. Here you have your m minus 1, so you have like your m minus 1, m minus 1 is equals to 0. So meaning you have your m minus 1 squared. So you have what we have real equal roots. Okay, so your m1 and your m2 are equals to each other, so meaning your complementary function, okay, your complementary function here is going to be equals to a plus bx, okay, bx, then e to the, our m is what? Our m is positive 1, which is just going to be x there. Then what about our f of x? Our f of x is equals to 4 sine what? 4 sine x, and this does not appear in the complementary function, so we can come and say our particular solution is going to be equals to since it's a trig function, this is going to be, we are going to show it in the form, or we're going to show it in the form, this is going to be in the form like c cos x, okay, c cos x plus what? D sine x. And we talked about this area in the previous video. That's why I was recommending, if you haven't watched that video, watch that video before you watch this one. Okay, so now we can differentiate our y prime of the particular solution is going to be equals to this part is going to give us minus c sine x, that will be plus d cos x. Then the second derivative of the particular solution is going to be equals to minus c cos x minus d sine x. Okay, so we can come and do the substitution there. You're going to say when you substitute where dy dx, we are going to say minus c cos x minus d sine x there, minus I'll say minus 2 open bracket the first derivative, which is our c sine x plus d cos x, then we say plus our y. What was our y? Okay, our y is just this part here. Okay, I'm just try to write this down. Okay, our y, it's c cos x plus d sine x. This is equated to what? 4 sine x. I'll say 4 sine x there, which is this one. So now we can say this is minus cos x, minus c cos x, minus c cos x minus d sine x minus 2c sine x minus 2d cos x plus you have cos x here, c cos x plus d sine x is equals to 4 sine x. So now you observe to say this part and this can go, this and that can go. Okay, so this simplifies it a little bit. So now we can have like minus what do we have here? Okay, so we have minus 2c sine x minus 2d cos x is equals to 4 sine x. Okay, then what are we able to do here? What it is that you can equate your cos with whatever cos that you have here. If we had one, then I'm going to equate this to that. So it simply means I'm going to say it's minus 2c sine x is equals to 4 sine x, of which is the same as this goes, that goes. You're equating minus 2c to what? To 4. So meaning my c is equals to what? Negative 2. Is that supposed to be negative 2 or positive 2? Okay, let me just check through if I've done the correct thing. Okay, this is supposed to be positive because here it was negative. Yeah, so that's supposed to be positive, so meaning this is positive and that's positive, so meaning my c is equals to positive 2. Then what about the d? It's obvious we are equating the d to 0, so meaning the d is equals to what? D is equals to 0. Okay, there we have it. So we have the coefficients that we are trying to determine here. So remember to say the particular solution formula was equals to c cos x plus d sine what? D sine x. So now I'm going to say y particular solution is going to be equals to our c. What did we have as our c? Our c, we had a 2, so 2 cos what? 2 cos x. If we put 0 here, that will just be what? That will just be a 0. So you can now come and say, okay, the general solution is going to be equals to the complementary function, which is our a plus bx e to the x plus the particular solution, which is 2 cos what? 2 cos x there, and there we have it. Okay, so I've talked about one with a trig function. I've talked about one that has an exponential function. uh, Let me talk about the last one, but of course this one is straightforward. We don't really have to uh, I don't think we have to multiply by x, but since I already looked at one that has an exponential function, I guess I can end here in this tutorial. Thank you very much for watching.